Hi, I'm Jackie Garofano, Chief Technology Officer at CCAT, the Connecticut Center for Advanced Technology. Our team is bringing to you a series of videos all about the power of model-based definition. MBD can be a really powerful tool when automating inspection processes. Here we have Nasir Mannan, our colleague at CCAT, as well as founder of M3DI, teaming up with Polyworks to show you how to set up strategies and make this a single button click.
Hi, I'm Nasir Mannan, Principal Engineer here at the Connecticut Center for Advanced Technology. Today we're going to be talking about how to leverage model-based definition to inspect a part using non-contact inspection technology. We're going to discuss two different systems, a M3DI VeriScan Flex 3D scanning solution along with the AOS 3D scanning software, and how that works with Polyworks Inspector software to extract measurement values from 3D scan data and to update an inspection report and export it out as a PDF file. The part we're scanning today is a sheet metal bent bracket. It's located center of mass about 8 inches up off this single axis rotary table. The scanning system is mounted on a 6-axis collaborative robot. We're going to go ahead and load up a general program to scan a part that fits within an 8-inch cube volume. Because it's non-contact, we can use that same program for any parts that fit within that volume. And then we're going to go over to Polyworks Inspector software and see just how easy it is for us to do a file import on a native Siemens NX file, pull in all of that PMI information so that we have our inspection completely set up and ready to go. So over in the AO software, we can go over to the automation tab. And generally, we would go over to Open and load up our generic program. In this case, I've named it Polyworks. And this program, as I mentioned before, is a generic program that can be used for any part that fits within an 8-inch cube volume. And the only thing that we have to set up on the robot side is the offset of that part from the rotary table. In this case, you can see that we're going to scan the part 16 times, so 8 times from the top vantage point. The robot is going to move the scanner so that it can see the part from underneath and scan the bottom of the part. And then it will export out the fully merged data set over to the inspection computer. Now, in this case, we have two different systems set up. One is the actual system that will grab the data, and the other system is the computer that will actually process or extract the measurements and fill out the inspection report from that data that we're grabbing from the scanning system. We could have this working on the same computer so that as the scan is finished, the inspection software starts up and it runs its process. But in this case, we want to be able to show how two different computer systems can be used. So at this point, this is all that's needed to set up the scanner side. We've done a file open, generic program to scan parts that fit within an 8-inch cube. Now it's time to go over to the inspection software and set that up to extract the measurements. We have already started the Polyworks Workspace Manager, and I can go ahead and launch Polyworks Inspector. Now that that's loaded, I simply have to do a import CAD models. And here we're going to be importing a native Siemens NX file. In Siemens, what we did was we added all the PMI onto that model, so it contains both the CAD geometry as well as all of the requirements that need to be inspected on that part. So we'll go ahead and just click that file, select Open, and on import, the first thing we're presented with is a PMI import log that shows us what was able to be imported and any errors or warnings that came through. So in this particular case, all of the PMI was imported. We have just one warning, and that is on the thickness measurement. It was imported as a custom control. All the rest of the PMI was imported successfully, so we can go ahead and close out of that. And in our 3D graphics view in Polyworks, we can see that we actually have already, just by importing the file with the PMI, all of our inspection is set up. Over here on the control reviewer, we can see all of those measurements are imported successfully. All we have to do now is start the file monitoring macro, and we can now execute the scanning program to actually scan the part, and for the scanning software to hand over that scan data to Polyworks Inspector to then extract all the measurement values. In AOS, back over in the automation tab, we're going to hit the Run Automation button to execute the program. And what's going to happen now is the collaborative robot will position the scanner head to the first vantage point, and the scanner will scan the part geometry while the rotary table is rotating that part through the 8 different views. In this particular case, the scanning solution uses fringe projection technology. It's projecting out a black and white stripe pattern on the surface of the part. The camera takes images of that fringe pattern as it's being deformed by the surface curvature of the part, and from that information, from that deformation of the projected signal, the scanning solution AOS is able to calculate the 3D point cloud of that particular surface from that vantage point. Because it is line of sight, the scanner does have to see different angles on that part, all the different surfaces that are needed to extract measurement values from. So there we had the second vantage point completed. The scanner is brought back to the home position. The rotary table is rotating back. The file in AOS 3D scanning software has been merged and exported out to the inspection computer. And now Polyworks is picking up that scan data set and extracting all the measurement values that were contained within this inspection program. Within a matter of 2 seconds, we are done with the inspection, and Polyworks has now gone back to monitoring that folder for the next data set. What we can do is view the exported out inspection report. So here we go into the directory that Polyworks is exporting that file to. We can go ahead and double click and view the inspection report. In this case, we've extracted out all the measurement values. The inspection report template was set up in such a way where we have images of what is being extracted along with the actual measurement values in the table. And that's it. In the 3D scanning software, if we're putting on the next part, and that is bracket number 11, all we have to do is specify that in the automation program. Here, we can change the name from bracket 10 to bracket 11, fixture the new part on, and click the button again to extract that new measurement values for the new part, and we'll see another inspection report show up in the directory. That's it. All we have to do is load up a program that is appropriate for the volume that that part can fit within from the scanning solution side. And on the inspection software, all we have to do is import model-based definition, start the macro server that will look for the handoff of the scan data set from the 3D scanning solution. Thank you for watching this video, one of many in a series of videos that show you how you can really leverage model-based definition to reduce your time and streamline manufacturing processes.
All that you've seen here today is available to you and your company. Our team of experts, the technology, as well as tech partners that help to unlock the power of digital thread practice. Together, we're here to help you to incorporate model-based definition and digital thread practice into your business. I'm Jackie Garofano, CTO at CCAT. Thanks so much for watching.